Okay, if you can see my slides, give me a thumbs up. Okay, recently we have cases where students can't see. So if you can't see, let me know. Okay, you might have to log out and come in again. So very quickly, let's go through, okay, pure substances and mixture. I think Zishan and Enlak, you have seen this 2 times. This is the 3rd time you're seeing this. Okay, just very quickly, I'll run through, right? I'll be giving you these slides, so don't have to copy anything. Don't worry about it. Right, so we know mixtures are made out of 2 or more substances. They are not chemically combined together. They are only physically put together, not chemically combined, right? Then you know about substances also, right? Okay, pure substances are actually those that are single elements. So single elements means found in the periodic table, or compounds, okay? So compounds are pure substance because they are not mixed with any other substance. This is an example of diamond. Diamond is actually made out of carbon, the element carbon. Yeah. Okay, so to separate solid, okay, there are many ways of separation. You need to know these few ways. One of this is magnetic attraction. So you use a magnet to separate out, okay, the substances that are attracted to the magnet. For example, here you have the iron filings. Okay, so the iron filings can be attracted to the magnet. So we use the magnet to remove the iron filings from the mixture. Okay. So filtration is the next one. We are trying to get insoluble solid from a mixture. So we separate it from the liquid. So in this example here, okay, you're going to see, okay, you can have like sand and water, chalk powder and water, clay and water. So in filtration, we need the filter funnel and a filter paper. Most important thing. Yep. So what is suspension? This is the definition of suspension. Okay. Right. What is the principle behind filtration? Right. Okay, you can actually see from the diagram, it's quite clear. Let's say I have a mixture of insoluble solid in a liquid, right? Okay, I pour it through the filter funnel. What will happen? Okay, what will happen is these large insoluble solid particles are trapped, right? So they are trapped by the filter paper in the filter funnel. So this is how the filter paper will look like if I were to zoom in a lot. So you see that there are holes within the filter paper. Small particles like the liquid can pass through, but the large insoluble solid doesn't pass through. So they are trapped in the filter paper. Right? So if you talk about this separation of sand and water, upon filtration, the solid that is remaining on the filter paper is called the residue. Okay, and then in this case, of course, it's sand. And then what passes through will then be water. We call it the filtrate. Okay, so there are names for these substances where they are positioned. So those that are trapped in the filter paper, a very general name will be residue. If you identify what is the substance, you have to look at the question, what is inside your mixture? Right? So whatever that passes through, we call it the filtrate. Okay, so filtrate can be anything that is the solvent. Okay, in this case, water. Now, we also can get back our solid, right? Okay, for example, the soluble solid by using this method, evaporation to dryness. So we heat the solution until all the water disappear, all boiled off, or evaporated. And then whatever remains behind will be the solid that we want. So we talk about salt and water. So this is salt solution. Okay, put in the evaporating dish. And then water in the solution is lost to the atmosphere. And then what you have will be just salt remaining as a white residue. See the term used again is called residue. So white residue left behind in the evaporating dish. Okay, so for those substances that decompose on heating, we cannot heat all the way to dryness. okay, like sugar, if we're going to heat it until it's dry, before it's even dry, you will already have this dark brown and black substance. Okay, this is actually carbon. That's why it's so black. Okay, when we heat sugar all the way, it decomposes. What's left behind is carbon. Okay, another way to obtain our soluble solid, okay, especially for those substances that decompose on heating, is to use crystallization. So the steps to take, okay, will be illustrated for you later. Example will be these substances. These are all soluble solids. Okay, they dissolve very well in water. So look at step 1 here, okay? Okay, let's say I have this impure copper 2 sulfate solution. Okay, so this is water with copper sulfate dissolved in it. It says impure, so there's likely to be some other substances inside. Yeah, so the solution is heated to remove most of the solvent. So I said last week and the week before, you heat it until you have half of the remaining solution. Yes, you can. All right. What happened is all these lessons are recorded. Okay. So let's say you sign up, right, for the tutorial. You can always watch the recordings again. Can? Yeah. At your own sweet time throughout the whole year. Let's say so long as you continue, you can watch it. All right. Okay. So that is when we get the saturated solution. So imagine you start off with probably this amount. Okay. And then you heat it until it is half the original volume. So this is known as a saturated solution. All right. Saturated solution. So after that, let the hot solution cool down, okay? And then your crystals will then start forming. In this case, we are trying to get our copper sulfate crystal. So it's going to look like this, okay? It's going to form at the bottom, okay, or at the base of this evaporating dish. And then after that, okay, we are going to filter it out, all right? And after that, wash with a little bit of cold distilled water to ensure any impurity is being washed away. Okay? All right. So the last step is definitely press between pieces of filter paper. That is your pure crystals. Yeah. So at the end of class, I'm going to show you a video to let you see how big crystals are formed. Yeah, I think I promised the students last week, right, to let you all see, but no time. So this week, we will have time, okay? We will have time, so you can watch the video later. Otherwise, I'll give you the link. You can watch it on your own. Okay. Now, this is actually separating two solids. This is their question. Chloe, did you receive the question? Did I send it to you last lesson? There was actually this particular homework to do. Did you recall?
I think so.
Okay, later I will show. Don't worry. Today I won't scold anybody for not doing work, but next lesson onwards, I'll be checking, and you must have good reasons if you have not done your work. Can? Try your best. Try your best to do. Even if it's wrong answer, remember, I'll be guiding you. If you don't let me know you don't know, okay, then you will never improve, right? Yeah, there's no chance for me to guide you to get the right answer. Now, let's say we have a mixture of two solids. Then you must choose a suitable solvent. And in the question for the last 2 weeks, you all have seen already. Okay, you're supposed to choose the right solvent to decide, how you are going to carry out the separation process. So we know that different solids dissolve in different solvent. Okay, the very common solvent will be water as well as ethanol. Very frequently used, and definitely so for your syllabus. So this is the similar question to the one you have in your handout earlier last week. So you separate sodium chloride and sand. Okay, so this is actually a solid mixture. We firstly must add water. Why choose water? Because sodium chloride, which is salt, right, can dissolve in water. Okay, so you get sodium chloride solution and sand. This is another mixture. But this mixture is easier to separate. What's the next step you do? You carry out filtration. Okay, so you filter the mixture, you are going to get the filtrate, which is the solution, right? And then the residue is the insoluble solid. All right. Okay. Here it says traces of the sodium chloride solution. Why traces? Because after filtration, the inside of the filter paper is still wet. Okay, it's still wet. So there are a little bit of this sodium chloride solution. Okay, so what's the next step? For sodium chloride solution, to get back your salt, you heat it all the way until it's dry. Whereas for the other one, okay, you just have to rinse with a little bit of distilled water and you get your clean sand. Okay. Now, we also talk about this method, okay, to get back the solvent. Just now we talked about getting back solutes only. Correct or not? We will heat the mixture until it's dry to get the solid, or we filter to get the solid. So now we want the liquid. We want the solvent back. What do? We carry out simple distillation. Okay, so this is actually the last second method you need to know. Okay, after distillation is chromatography. So in simple distillation, at your level is easy. In Sec 3, you're going to revisit this topic and you're going to learn more things about separation technique. Okay, so why is it that you always have to do that? Like in primary school, you learn a little bit here and there. Then secondary school, you relearn again. Yeah, but the knowledge is more difficult, right? Okay, more tough. Fractional distillation, I will be teaching. All right, I will be teaching for sure. Okay, because some schools choose to test the students on fractional distillation. Some schools do not. So to play safe, I teach lah. I teach is easier for you all to handle schoolwork. Right. So look at this one now. Extraction of water from seawater. Okay, extraction of water from salt solution. Extraction of water from sugar solution. We are basically just trying to get back the solvent. All right, so this is the setup. In the science lab, the setup is massive. It's not going to be easy for you to do the setup on your own. You will usually just see the teacher setting the whole thing up at the teacher's bench. And then the teacher will ask you all to come in groups to go and take a look at the setup while the teacher explains what is happening. Okay, so you have the thermometer. Thermometer must always be positioned this way. Questions will ask you to identify error in the setup. So sometimes the error in the setup, you will have the thermometer. Okay, the bulb of the thermometer is right inside. Okay, so this is a wrong position, right? So must know how to position the thermometer. Yes, Zishan?
Thermometer, although it's opposite, but then it's still right. But sometimes, so basically our school gave us a paper, a practice paper, for the actual exam, and then the thermometer inside there looks exactly the same as it's never, although it's upside down, but then it looks like it's not.
Right. Then you have to let your teacher know that the drawing is misleading. Yeah. Okay. So the trick question was upside down, Anna. Okay. So you be careful. Sometimes they put the bulb of the thermometer here. Okay. So students tend to lose marks here. 1 mark. Okay. Students tend to lose mark here. Okay. Why is it that the bulb of the thermometer must be at the opening? Because when we heat this mixture, okay, let's say this is water, right? Water evaporates, it boils, it evaporates. So this is actually water vapor, okay, which will rise and then enter the condenser. So this is the opening into the condenser. So you see, this vapor must definitely touch the bulb of the thermometer, yes or no? Why is this important? Because we want to know what is the thing that comes through and gets collected here. If we don't have the reading, we wouldn't know what is this liquid we are collecting.